Անգլերենը գոհակի հայերենի բարապաշարը թուչի տալիս էլի, որ սեմայ մասին հայերեն խոսամ ոչինչ, ներմեք ինձ Անգլերեն, okay. Okay, so we'll discuss this in English. Okay, so the title of this presentation is Principles of Clean Code. So first, what do I mean by clean code? So by clean code, I mean code where any developer can read the code and clearly understand what it says. Okay? That's literally all that means. Okay? It's code that is easy to understand for humans. Okay? So why do we need to write clean code? What is the purpose? I mean, the whole goal of writing programs, of coding, if you will, is to write a bunch of characters that then the computer interprets and executes, right? So you would think we're writing code for the computer, right? In reality, that's true, but kind of. It's actually very important for us to write clean code for humans to understand for a few reasons. First of all, most of you, I'm guessing, the ones that are coding, work with a team. If you work with a team, that means there are other people who will be reading and trying to make sense of what you've done. So writing code that is clear to understand is really important in that regard. The second reason is that it actually reduces the number of bugs you have in your code. So code that is written simply and clearly actually has fewer bugs than code that is written in a really weird, complicated way. And we'll see some examples of this moving forward. Lastly, and this is really the most important reason why you should write clean code, is to do yourself a favor. You as programmers. Why? Well, I don't know if you guys have noticed this, but you spend much more time reading code than you do writing code. I don't know if you've noticed this. And if you haven't, the next time you're at an office or somewhere where there are a lot of people coding, pay attention to what they're doing, right? Look at them when they're actually working, not writing an email or writing a text message or something, when they're actually coding. And see what they're like. Are they like this? You know, where they're constantly just typing away? Or is it more of a, where they're just staring at a screen trying to figure out what the heck they've done, right? Usually it's the latter, right? Lots of research has been done in this regard, and more often than not, we spend our time reading code. When you're debugging, you are reading code. In fact, you're doing more than reading code. You're not only reading code from top to bottom, but sometimes you're stepping into functions, looping around. You are reading. That's what you're doing. You're reading your code. You're trying to understand what's happening. Every time you debug, every time you sit down to write your code, any code, you first have to read the code that's there in order to understand how your code is going to fit in, right? Every time there's a bug, they send you, now you have to read through that logic and figure out what you've done. You're always reading code. So it's very important to write code that is easy to understand. That is my premise. Okay? So, what can we do to write clean code? First, a warning. These are my opinions, okay? This is just, everything that I'm going to share with you, for the most part, are things that I've learned while coding. So if if there's some book that I don't know about that specifies standards for writing clean code, don't, yell at me and say, but these are just my opinions. So, with this warning, let's begin. So the first thing you should do, in my opinion, is to keep your code simple. Simple code is easier to understand than complex code. I think everyone would agree. So the question is, okay, fair enough. How do you write simple code? Well, one thing you can do is write less code. What's easier to understand than less code? So then the question goes, how do I write less code? Now notice, I'm not telling you to write simpler systems. Yeah, inch. I'm not asking you to write stupid systems or simple systems or systems that are not powerful and interesting. That's not what I'm saying. What I'm saying is do all that, but at the same time, write less code. In my experience, the best programmers are the ones who produce most complicated systems, but by writing the least and simplest amount of code to do it. That is skill, right? So how can we do this? What are some ways we can do this? Well, for one thing, use frameworks and libraries. That's what they're there for, right? Avoid writing boilerplate when you can, right? If you're going to be doing massive amounts of data binding, I do a lot of client-side development, so I'll bring this as an example. If you're doing data binding in your DOM, One way to do it is to select everything with jQuery and one by one fill in the values. That's one way, but you end up with bulk. Another way is to use a framework. Knockout, Angular, Ember, these are actually, Knockout is a library, not a framework. We'll get to that in a moment. Angular, Ember, these are all frameworks, right? And these are just the frameworks I'm talking about in JavaScript. There are frameworks for PHP and Java, you guys know these. Learn to use frameworks, that's what they're there for. Frameworks are the efforts of other engineers to make your code cleaner. That's what a framework is. Libraries as well. Look, if you spend a lot of time trying to figure out a system, you are trying to, oftentimes you write code from scratch, okay? You want to perform some action, you write code from the beginning. And then you have to write documentation for that code. And then you have to unit test that code. And then you have to actually go through the cycles of using the code to find the edge cases to then fix the code and debug the code. You've just lost a lot of time, right? That libraries, on the other hand, already are out there. There's already a community around it. There's already unit tests around it. There's documentation around it. When you can, use a library. Don't go it alone. It's another thing if you want to just write code to learn things. That's the whole, everyone should practice coding. Don't get me wrong. But when you're in production and you want to minimize the code base that you are then going to be responsible for once it's released, do everything you can to minimize that impact. Because if that code fails, you're responsible. You're the one that has to debug it. You're the one that has to, in the future, add features to it, etc., etc. Quick thing. See, I want to distinguish one thing, because I notice a lot of people get confused libraries and frameworks. There's a clear difference between the two. With a library, you write your code, and then when you're ready, you call into the library to perform some action for you. Okay? John? Okay. Okay, that's just of Goldie and Galsen is. Okay, right. So with a library, you call into the library. So you control the overall flow of the logic, and then you call into the library to perform some action, right? With a framework, it's the exact opposite. The framework controls the overall structure of the system, and then calls into your code when it decides, right? So that's the difference. So be careful how you use framework and library, okay? They're actually two very different things. Okay. So this is really important. By the way, is this out of focus? It's actually in focus. Whatever. Okay. So write code that looks familiar. Okay. So what do I mean by this? Well, if I talk to you, right? We agree that yes means yes, right? Yes means I/O, right? Okay. Now imagine if I were talking to you and I used yes, but I actually meant yes to be car. Weird, right? You would agree. So in language, it's obvious. It doesn't make sense to use things that are not standard, right? In coding, the same rule applies. If you're using a convention of naming your variables one way, you should stick to that convention. A variable that means $sign should always mean the same thing. In general, in JavaScript, $ is assumed to be jQuery, right? Most of you probably know this. Don't use $sign to mean something else, because right away, people will understand it. They'll follow your logic and understand that, okay, he actually meant car, not yes, right? They'll figure it out, but they shouldn't have to go through the exercise of doing so, right? Stick to convention. This is really, really important. Data structures, okay? Know your data structures. Know the difference between, first in, first out, between a stack and so on, and name your variables accordingly. If you're creating an undo stack, name it an undo stack, because everybody, for the most part, knows what an undo stack is. Don't make up a name and then force someone to try to figure out what the heck you did. Okay? Stick to convention. Furthermore, even within your own code, when you begin to develop a style of how you write your code, and you begin, try to repeat it. Because once a person reads one of your functions and understands what you did, they should be able to apply some of these assumptions to understand what you did in the next set of code. I mentioned always follow convention. Convention not only makes your code more readable, it actually reduces the number of bugs. How many people can't, let me zoom in here. How many people can't see this? Can everyone see this? I'll zoom in more, just in case. Okay. I love putting JavaScript on slides, so here you go. It's important to follow convention, as I said, not only to make code readable, but also to reduce bugs. For example, and this is just one example to illustrate the point. In most programming languages that you guys have used, Java, C#, C, it really doesn't matter whether you put your curly braces on the next line or on the same line, right? Usually people argue, oh, I like to put it here, I like to put it here, but honestly, it really doesn't matter for the most part. What matters is that you stick to convention. So if you work at a company that puts it in the next line, everybody should put it in the next line so that your code doesn't look half this way and half that way. Right? You would agree, it's just weird. But convention actually goes beyond that. It actually reduces bugs. If I were to uncomment this line, can anyone tell me what it would print? Undefined. Yeah. Crazy, right? No one would, I mean, you would think, wait, why? This doesn't make any sense. Well, actually it does. JavaScript has what's known as semicolon insertion. And what it will do is it will look at read to return, just put a semicolon here and return nothing, undefined. Right? So if I were to follow the convention and instead always put my curlies on the same line, this bug would never happen. Right? So stick to convention. It will reduce the number of bugs that you create. Okay, a few a few details. I try to always avoid nesting as much as possible. So in this case, we're trying to see if foo is truthy, and then if bar is truthy, and then this is where we actually put the code that matters, right? I prefer to do it slightly differently. Do whatever error checking and validation at the top. So when you read this, you right away say, okay, and you jump over and you read this. You never even bother with this part. You focus here. Makes it easier to read. I don't have a lot of time, so I'm going to go through this a bit faster. Keep variable names short but descriptive. Don't do too much in a single line. Okay, I have to say a few things. So I worked with a guy before who was a really good programmer. The thing is, he was kind of full of himself, and he always wanted to show how good he is. And I kid you not, I opened up his code once, and there was an entire algorithm, almost, that was written in basically one line. Like, he had regular expressions in there, he had like a function where the return was being passed to another function, and it was all in one line of code. Crazy, right? Now the thing is, the actual logic of steps that he was doing there could have just as easily been represented in a regular logical flow. But just to show off and effectively make his code more complicated, he did it all in one line. This makes it harder to read, harder to understand, harder to debug. Avoid it if you can. Built-in obfuscation. That's not, okay, we can talk about that later. All right, design systems in a series of modules. I think we've studied sort of object-oriented programming is great, right? We all kind of know this, but seriously, if you think about it, don't design a complicated system. Design a system that's made of small individual parts that are simple, but when combined together, produce complexity. Think of it that way. Nobody sits down and writes an operating system. Nobody. Nobody sits down and says, the first line of my operating system will be, and writes, people write pieces that when combined together, create an operating system, right? That's the only way. Otherwise, it's too complicated. No one will make sense of it. There'll be too many bugs. It's too hard to test. Too much. Maintain what's known as high cohesion within your modules. What I mean by this is the degree of which pieces within a given module are similar. Another way to describe this is keep your code properly organized. If you have a person module, don't add things into that module that have nothing to do with person. Properly organize your code. That's it. Write loosely coupled code.
Okay, so what do I mean by loosely coupled code? So you have a module that has a whole bunch of stuff that it does here, and you have another module that does a whole bunch of stuff over there. But this module doesn't need to know all this complicated stuff that's being done over there. All it wants to do is it needs a channel, a window, through which it can communicate with that module. But it's important that this module doesn't have to understand what happens here. Let me give you an example. You go to order pizza. Right? You go to a shop and you order pizza. All you care about is that you talk to the person who will later just give you a pizza. You don't go over there and try to figure out how the pizza is made, although I guess it's not too complicated, but you don't care how a pizza is made, technically, right? All you care about is the transaction, that you give the person the money and they give you the pizza. The complexity of making the pizza, what oven is being used, how long the pizza will be in the oven, etc., is abstracted away from you. It's not your concern. This is what is often referred to as separation of concerns. What I care about and what you care about stay separate. The parts where we interact, our APIs, are windows through which we interact. I have 5 minutes. Thank you. That's what matters, right? Okay, let's hurry up. Okay, I've had so many arguments with people about this. It's driving me crazy. When you write a function, don't ask for more than what you need. Okay? In this example, this function is asking for a manager just so that it can take the ID from the manager and then use it somehow. So you might wonder the question, why are they asking for a manager? Why don't they just ask for the ID? Right? And if you think about it, this does two things. It makes the code less complicated, right? This is less complicated than this, so this is more readable than this, right? Number one. Number two, this is easier to use than this. So anytime you're writing functions, anytime you're writing APIs, keep this in mind. Don't force someone who used your code to do more work than they have to. I shouldn't have to make a manager just so I can call this function, when all it needs is an ID. It doesn't make any sense, right? Okay. Global variables are evil. There are lots of reasons for this, but I'll go through just a few. Global variables don't have locality. What do I mean by locality? Well, when you're looking at code or you're trying to reason over some code, the scope of a variable matters. In other words, if the scope of a variable is to about this many lines of code, understanding what that variable does and all the different states the variable can be in, reasonably straightforward. If you have that much, it's a little harder, but you can still figure it out. When you put it into global, it's that much harder, right? Because you've lost locality. You don't know all the things that can happen to that variable, right? Unless you look at the entire system, which we agree, once you combine all the modules together, the result is a very complicated system, which you don't want to reason about. Okay. By the way, are you guys following what I'm saying? Or? All right, cool. Okay, global variables have no access control, right? By definition, they're global. Anyone can access it. This should scare you, right? Because that means you can't rely on the global variable being any particular value, because any part of the system can change it at any time, unless you start putting locks on it, and that adds a whole other layer of complexity. Not to mention race conditions and blah, blah, blah. So, one more thing. Global variables lead to namespace pollution. A lot of times people make the mistake where they'll think that a variable is local, or they'll forget to declare it locally, and they use it, but in reality, they're actually modifying the global variable. This happens in JavaScript all the time, but it's not limited to JavaScript, right? So, try not to use global variables at all. If you have to use them sparingly, is my advice. Die. Who knows what die stands for? Duplication is evil. Duplication is evil. Avoid copy-paste. The problem with copying and pasting is that if you have duplicate code and then you find a bug in one of the pieces of code and you fix it, you still have a bug in the other piece of code, right? Plus you have a bigger code base, and as I said, write less code, right? So this goes against that logic. Avoid spaghetti code. Okay, so how do I define spaghetti code? I am so short on time, I'm sorry. So spaghetti code is where logic is the control flow of your code is sort of interleaved and almost illogical. It's difficult to follow. An example of that, by the way, is I was working with a company that had a system where they had, it was a user interface, and they had two views on their screen, okay? Two parts in the application. One part was editing the name, and one part was showing a name. And what they did was, every time you would edit the name, is they would jQuery the application, finding all the other elements that had that name, and then update those elements based on that value. But then they introduced another view that edited the name here. So now they had to keep this in sync with that and this. And suddenly they ended up with this spaghetti. One way to solve this, and the way I solved it, is knowledge of model view controller. The way to avoid this is, rather than directly modifying one view to another, is each view should simply read and write to and from a model. So there's one model. All of the views, all the pieces of the UI read from that model, and then if one view wants to modify the value in the model fires an event, a change event, which then all the views respond to and update. That is a much cleaner approach. So, design patterns are useful to know. CRUD. Who knows what CRUD is? Create, read, update, delete. If you are writing REST APIs, or actually server APIs in general, and don't know what this is, please read about it. I was working with a team in India where they were not using CRUD. They had a separate random function. First of all, they were doing post for everything, which is weird. But also, they had a separate function call, like a separate REST call for every action in the application. And that made it very difficult. I'm getting there. I'm almost done. Paging. If you ever call anything, any service that returns a list, that service has to support paging. Always. Never even bother getting into an argument about this. Why? Suppose you get a result that's huge. What happens to your system? Breaks, crashes, burns, right? Okay, so every API that you ever write on the server that performs some query and returns a, oh crap, the end. Write unit tests, comment on code. If your code is too complicated, rewrite it. Don't comment about it. Shut up and code. Okay, one last thing, and I promise I'm done. By the way, the shut up and code was, the only way you're going to get good at this is to write a lot of code, so that's where that comes from. Okay, so this comes from, this is the last thing, I promise you, last slide. So these I took from the Unix philosophy, and I love it. It's awesome. So first thing, iterate quickly. Okay? Don't spend too much time over-designing a system. Your prototype is, you're going to learn more from building a prototype, from actually sitting down and trying to build something, than you ever will by sitting there and trying to figure it out on the board. Not to say that you shouldn't brainstorm, but write code. Just do it. Refactor ruthlessly, right? By the way, this is why you need unit tests. Because if you change code, how do you know you broke something? Maybe you didn't break something. You have no idea. Unit tests are what make sure that you don't break code when you move things around. Refactor, keep code clean as you're working. Last thing, rewrite bravely. Don't fall in love with your code. I've personally thrown away more than 99% of the code I've ever written. Either because I rewrote it or because I just threw it away. For whatever reason, don't fall in love with your code. If there's a better way to do it, throw it away, do it again, do it right. Okay, that's it. Thank you.